I saw this video on YouTube.
No, people keep saying he's not really gone, as long as we remember him. Still hurts.
I see no evidence of physical injury.
It's a different kind of hurt.
You are my patient. I would like to help.
You can't fix this one, buddy. What are you doing?
I am downloading a database on personal loss. Database downloaded. Treatments include contact with friends and loved ones. I am contacting them now.
No, I don't do that.
Your friends have been contacted.
Unbelievable. Now what are you doing?
Other treatments include compassion and physical reassurance.
I'm okay, really.
You will be all right. There.
Thanks, Baymax.
I am sorry about the fire.
It's okay. There was an accident.
I want my robot to have same function. My idea is that machine saw my face expression emotion and do something according to my emotion. The hardware I use is Jetson Nano, CSI camera, speaker. The reason why I'm using Jetson Nano, because I had built one inmoov robot during my free time. I'm trying to use Jetson Nano to be its computing hardware. I'm trying to use less resource to build my functions prototype. Thus, my idea is to do transfer learning, not build neural network from scratch, and test if it can work well. First of all, I want to let machine know my emotion through computer vision. I use the pre-trained model ResNet-18 for transfer learning. The reason why I'm choosing ResNet-18 to be pre-trained model is its cost-effectiveness of accuracy, and training time compare with other small pre-trained model. The code explain. I set my code into 3 parts: emotion, pinned, dataset.py, utils.py. The dataset.py is to create and manage dataset. The utils.py is to do data per process. First I set image to PIL format and turn to PIDH tensor. I set code to run inchpoo. I normalize the image by mean and standard deviation to reduce the scale of the image data. Last, I add an extra dimension to the processed image to match the input requirements of the model. Usually the batch dimension, the emotion, pinned is the main code. First I set up the CSI camera. Second I set the category to classify. I set for categories are none, happy, sad, and angry. Third I build widget to help me connect data. Fourth I load pre-trained model and change its last layer to my categories. Fifth I build speech response. Sixth I set up my neural network for training my new data. I set epic at 8. Because the bigger epic the more RAM it use and more risk in overfitting. My Jetson Nano only have 4 gigabits RAM. They have a paper in 2018 called Revisiting Small Batch Training for Deep Neural Networks. It shows the beneficial using small epic. The optimizer I choose Atom because its convergence is more faster than SGD. The precise in Atom and SGD is same in this task. The loss function I choose cross entropy. I set gradient be 0 in the beginning of every epoch. Because Atom and SGD will accumulation gradient in every epoch, I use backward propagation to adjust parameter. Last is to display all the widget. And now is the result and experiment. First I add the data of non-emotion. Second I add the data of happy emotion. Third I add the data of sad emotion. Fourth I add the data of angry emotion. I had test 40 pictures work well, but here I demo adding the data. So I'm using 50 images to train in every categories. I set epic is 10, waiting for the training.
How can I assist you? I'm glad to see you in such a good mood. How can I make your day even better? I'm here to listen if you want to share what's been bothering you. It looks like something might be bothering you. Would you like to talk about it?
Potential research opportunities, exploring improvements in deep learning models, creating diverse and larger datasets for more accurate emotion analysis, applying emotion classification in practical applications, and expanding the range of emotion categories considered. enhanced human-machine interaction. Contributions can be made by sharing code, tutorials, and expertise to help fellow developers. The impact: enhance user experiences in emotion analysis, smart monitoring, and robotics, education, entertainment, and business with embedded system. This is my presentation. Thank for your listening.